talk about writing ratios and solving proportions. And so the first thing we have to make sure we understand is what a proportion is, and you said that it's a fraction that is equal to another fraction, and that's correct. We're going to say it's a statement. That sets two ratios equal to each other. So a proportion is a statement that sets two ratios equal to each other. And a ratio is just a fraction. We compare two things. You want to compare how far you've driven and how much gas you've used? What's our ratio? If we want to compare how many miles we've driven and how much gas we've used, what's our ratio?
Miles to gas.
Okay, miles per gallon, right? If we want to compare how far we've gone and how long it took, then what's our ratio? Miles per hour. Okay? Two ratios that we're probably pretty familiar with. How many of you have to pay to put gas in your car? Okay, a few of you? How many of you liked it when it was $1.76 a gallon? And even now that's gone up to $2.09 or whatever it is here in East City.
It was $2.10 when I drove by this morning.
Okay, $2.10. And even that, it's way cheaper than it was before. So even that doesn't upset us too much. All right. So ratios are just comparing two things, and then when we write it as a proportion, we're taking two ratios. They're comparing the same two items, and we put them equal to each other. Okay. Pause for a moment. An extended proportion is just writing three or more ratios equal to each other. If you forgot to shut your phone off, probably should do that. Oh, sorry, I didn't realize I was recording all this dead air. Later in the chapter, we're going to compare triangles that are similar to each other, and the sides are going to have a special relationship that deals with proportions. Okay, and extended proportions would be a good example of those sides. How many sides does a triangle have? 3. And so if we're comparing two triangles together, then when we compare each corresponding side, we'll end up with 3 ratios. Okay? And not to let the cat out of our bag, but those 3 ratios will have to be equal to each other. And that's an ideal example of where we're going to use extended proportions. Okay? All right. The property we want to talk about is called the cross products property. And I'm pretty sure that you will be familiar with it. Make my D look a little better. B is equal to C over D, that's proportion. My ratio A over B is equal to my ratio C over D. And if I want to rewrite this so it's no longer in ratio form, we can use the cross product property to do that. And what would that give me then? A times D is what? C times
B.
B. I'll go ahead and write it B times C. Okay, so AD is equal to BC. It's the cross products property. Okay? I'm just glancing to see if they used. Yeah, they do. This is also known sometimes as a means and extremes property. A times D is our extremes. And B times C is our means. Okay? I think of it as, if I went in order like this, okay? A is the first one I would come to, D would be the last one I would come to, and I think of the A and D as on the outside, the outer two, and so those are on the extreme ends of this, and so that's why that's how I remember to think of A and D as the extremes, and B and C are in the middle, and I think of the middle as the means, and I don't know if that'll help you or not, but that's the way I think of that. Okay, so we have the means and the extremes property is the same as the cross products property. Okay? So in the scale drawing, the scale compares the lengths of sides in the drawing with the actual lengths in real life. Okay? When you build a house, you're going to use a scale drawing. It's called the what of the house? Anybody know? Louder, please. The blueprints. Okay? The blueprints will have the actual, picture of the house, but it will have the lengths. It'll tell you exactly where to put windows, where to put doors. It'll tell you where to put walls. It'll have every dimension you need to have. It'll be on there. Okay? That blueprint is a scale drawing because it's going to take the picture of the whole house and put it on a little sheet of paper. It might actually be a big sheet of paper, but it's still, compared to the house, it's going to be very small. Okay? And so the scale drawings are very important, and you don't have to necessarily be a carpenter to understand or need to understand what a blueprint looks like and what it does. What most of you, if you are going to have a house built for you and you're just going to select a house and say, this is what I want, most of you are just going to look at pictures called floor plans. They aren't going to have all the exact dimensions of where the windows and the doors and all those things go exactly. They're just going to show you what the room's going to look like and the plan of the house is going to look like. And they'll have where windows and doors are, but it may not have exactly where the measurements or what the measurements are to put them there. So we have a couple different thoughts there on scale drawings, but the blueprint is what you would need to actually draw the house. Unless you build the house, unless you've done a lot of building, and then you probably could take a picture and make all the adjustments yourself. For my last house, I drew my own blueprints just on a piece of graph paper, and it wasn't by any means complete, like if I bought a set of blueprints, but the problem is I couldn't find a floor plan that I liked, and so I just made up my own. And sometimes that creates some problems, but it worked out. So, any questions on what a scale drawing is? All right, I want to do a couple examples of solving proportions. Simplest ones would be like x over 4 is equal to 5 over 9. An example of a situation where it's not necessarily going to be nice numbers, but the process is going to be the same. So if I use my means and extremes property or my cross products property, what would I do here?
Multiply x and 9 together.
Okay. So 9 times x equals
20, or 4 times.
4 times 5. And so if I divide both sides by 9, I get x is equal to 20 ninths. Right? Which is 2 and 2 ninths, or if we want to round it, we would say that's 2.2. Did I ever show you the fractions for ninths? 1 ninth is equal to 0.1 repeating. 2 ninths is equal to 0.2 repeating. 3 ninths is the same as 1/3, isn't it? And that's going to be 0.3 repeating. 4 ninths is, what do you think? 0.4 repeating. 5 ninths. 0.5 repeating. 6 ninths, same as 2/3. 0.6 repeating. 7 ninths is 0.7 repeating. And 8 ninths is 0.8 repeating. 9 ninths would be 0.9 repeating. Well, actually, it's 1, right? 9 ninths, 1. Okay? So, just if you have to make decimals, ninths is a real easy one to do. Okay? All right. Any questions on that? Any questions on how we solve this? Okay, let me do one more where it's not quite as easy. If I have x plus 2 over 7 is equal to x minus 1 over 10. Okay? Again, I just made this up, so my numbers might get really ugly, but it's the process I want to make sure you understand. Many of you will do this. 10 times x plus 2 is equal to 7 times x minus 1. Is that correct?
No.
Okay. Is what I said correct?
Yeah.
Yeah. But did I write it correctly? No. What did I do wrong? I have to have parentheses. I have to make sure that when I multiply 10 by x plus 2, then I'm multiplying 10 by all of the x plus 2, not just the x. And when I multiply 7 by x minus 1, I have to make sure I'm multiplying all of x minus 1 times 7, not just the x. Okay? So I really need to make sure I put my parentheses in. So I get 10x plus 20 is equal to 7x minus 7. Okay, and so if I subtract 7x from both sides, I'm going to subtract 20 from both sides. Oh, and it didn't work out to be an awful answer after all. So it's 3x equals negative 27. You agree with that?
Yeah.
Divide by 3. X equals negative 9. Okay? X is equal to negative 9. If I went back and plugged that in, what's negative 9 plus 2? Negative 7 over 7 is? Negative 1. What's negative 9 minus 1? Negative 10. What's negative 10 divided 10? Negative 1. It checks, doesn't it? Okay? Here's my answer. All right, so the hardest problem in the whole lesson is going to be not forgetting to use parentheses. And some of you are going to say, oh, I don't need parentheses. I won't forget to multiply the whole thing. And guess what the first thing you do on the test is? Forget to multiply the whole thing. Guess what one of the answer choices is going to be? The wrong answer you get? Right?
Right.
Almost always. Okay? So be prepared. Aaliyah, you going to be okay? You mad that bus came and picked you up this morning?
I'm mad that my pencil doesn't like me.
Who doesn't like you? Your pencil?
Yeah. A lot of people don't like me, but my pencil's very good.
No. Well, I'll get you a pencil that won't run from you. All right. Do we have today's
Thanks,
assignment?
my life.
There's your assignment. 2 through 42 evens.